Good morning, friends. So in the previous lecture we did the exercise 12.1 and we saw the laws of exponents and powers. So I hope by now you have understood how to use them properly. In today's lecture we extend the same chapter in the use of exponents to express small and large numbers. Now where do you come across very small and very large numbers? So here there are some facts which are stated for you, scientific facts. The distance from the earth to the sun is this big, right? We have to learn to write this in the proper notation. The unit here is meter. The speed of light is considered to be 3 lakh kilometer per second. So that is, if we count, it is 30 crore meter per second. So this is a huge number. Now, thickness of a book is 20 millimeter. That is quite small. Yes, so we are starting from very big, moving towards the very small. A red blood cell inside the human body has the size of 0.000007 millimeter. This is a very small, minute number. The thickness of the human hair is from the range of 0.005 centimeter to 0.01 centimeter. So what you can see here is numbers which are very big, measurements which are really very big to measurements which are really very small. The distance of the moon from the earth, yes, is quite a large distance. The size of the plant cell is quite small in nature. The average radius of the sun, the mass of the propellant in a space shuttle is given in kg. The thickness of one piece of paper is given as 0.0016 centimeter. The diameter of a wire on a computer chip is really very small. The height of Mount Everest. Technology is now increased to such a level that we can now go to very small measures because of the help of the electron microscope. And you know the James Webb telescope, which is sent into space, is now traveling a vast distance in the universe and is bringing pictures of galaxies very far away. So that is a very huge number, but here we have taken only a very few examples. Now we'll use exponents and powers to write all these distances or all these measurements in a standard form. So what is a standard form? What is the rules of writing numbers in a standard form? There are basically rules to write one non-zero digit, a non-zero digit before the decimal point. So we will have only one digit written before the decimal point. Only one digit will be written before the decimal point, and that digit has to be a non-zero digit. All the other digits are written after the decimal point. So this number 15000000000, here the first non-zero digit is 1. So I write 1, then I put the decimal point. After decimal point there is 5. Now when I have written this 1.5, so what is actually done here? You can see this number can be written as 150,000,000. So you can see 150 I have written, 000,000. Now the last three zeros I don't write, I only write two zeros and I write into 10. Can you see what I did here? I took this zero separately as this number into 10 gives me the whole number. Or I can write this 150,000,000,000 into 100. Or I can write 150,000,000 into 1000. So you can see what I am basically doing. Are you following? What I am basically doing is this whole number I writing as multiplication of power of 10. So you can see what I have done here. So I can also write this as 15 into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 2, 3, 4, 5, 6, 7, 8, 9, 10. Now this becomes 15 into, so 10 can be written as 10 raised to 1, 100 can be written as 10 square, 10 raised to 2, 1000 can be written as 10 raised to 3. You know 10,000 can be written as 10 raised to 4. Why? Because 10,000 is 10 into 10 into 10 into 10. That is 10 raised to the power 4. So here there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I can write it as 15 into 10 raised to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry, I have to write it 15 into 10 raised to 10. But the rule says, the standard form says only one digit before the decimal point, and that to a non-zero digit. So I can write it now as 1.5 into 10. Why? Because 1.5 into 10 gives me 15 and into 10 raised to 10. So the total number becomes 1.5 into 10 raised to 11. So this is writing the number in the standard form. I hope you have understood it. Writing the numbers in the standard form. Now we'll try a shortcut trick to write the number. So what is the shortcut trick to write the number is moving the decimal points. Okay. So remember what I have done here is I have tried to explain to you how to write big numbers. So this big number could be written as this much into 10 or this much into 100. So I am shifting 1 0 from this side to the other side. You can see ultimately I shift all the zeros. So what do I do is I know in the standard form one digit comes before the decimal point and that has to be the non-zero digit. So you have to see how many digits are non-zero digits. So here there are two digits which are non-zero digits, and after the first digit you put the decimal point. So you have to write 1.5. Why? Because all the non-zero digits have to be mentioned. All the non-zero digits, so there is only two non-digits number. So here comes the decimal point. Now you see this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So what is actually happening here is initially there was no decimal point. When a number doesn't have a decimal point, we consider decimal point to be at the end of the number. Now the decimal point is shifting towards the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. Because it is shifted 11 places, I get 10 raised to 11. So in the same way, you can see here in the second sum, we have got a one digit number which is a non-zero, only 1. So the decimal point should come after this. So actually how is this sum done? This sum is done like this. 0.000007 is written as 7 upon 1, 2, 3, 4, 5, 6. 6 digits of decimal points. So 1, 2, 3, 4, 5, 6, or written as 7 upon 10 raised to 6. And when this number goes in the numerator, it becomes 7 into 10 raised to minus 6. Okay. So in the shortcut method it is, the decimal is here, it should come after the first 0 decimal digit. So I have to bring it after 7. So how much I'm shifting to the right? This decimal point is shifting 1 space, 2, 3, 4, 5 and 6. Because it is moved 6 spaces to the right, the number becomes 7 into 10 raised to minus 6. So I hope you are remembering the shortcut. This is the actual method. But the short method is, when you move the decimal point to the left, the power is positive. If you move decimal point towards the right, the power becomes negative by the number of places. Now let us see if you can apply this things in the next sum. So the next sum we have got 3 non-zero digits. Okay, 3 non-zero digits. So all these 3 digits have to be mentioned. You can see here I mentioned 1.5. There were 2 non-digit numbers 1 and 5 which have been mentioned here. Here there was only one non-digit number, so it is only written as one non-digit number. But here there are 3 non-zero digits. Sorry, there are 3 non-zero digits. So I have to shift it after the first non-zero digit. So that is, which is the first non-zero digit here? That is 5. So the decimal point has to be shifted after 5. So let me shift from here 1 space, 2 space, 3 space, 4, 5, 6 and 7. The decimal point has moved 7 digits to the right. So this number is written as 5.64 into 10 raised to minus 7. So are you understanding the rules? Again, let us see the rules of writing the number in the standard form. Okay, what are the rules? I hope you understood the rules. See it again. First rule is, we have to mention all the non-zero digit numbers. So there are 2 digits here, both have to be mentioned. The decimal point comes after the first non-zero digit. So here it should come after 1. Then the decimal point is over here, is shifting towards the left. So the power will be positive. If the decimal point is shifting towards the right, the power will be negative. Okay, here there are 3 non-zero digits. The digit comes after the first, the decimal point comes after the first non-zero digit. So it should come after 5. So how much the decimal place is moving to the right, that much negative power you have to put. So this is writing numbers in standard form. So the fourth one I think will be very easy for you now. You can guess the answer and check with mine. This is 2.1. 1, 2, 3, 4, 5 and 6. The decimal point is coming here. So 2.1 into 10 raised to minus 6. For the next sums we have again, we'll continue writing the same 3 digits here. So I'll write is at 2.16. All the 3 digits have to be mentioned with the decimal point after the first non-zero digit. There is no decimal point here, so the decimal point is at the end, moving 1, 2, 3, 4, 5, 6 and 7 points to the left. So into 10 raised to 7. Again here there is no decimal point, so the decimal point is taken to the end. There are 4 digits here, so I have to mention all 4 with the decimal point after the first non-digit number. So it is 1.524, 1, 2, 3, 4, 5, 6 and 7 again into 10 raised to 7. So this is the basic way of writing numbers in the standard form. You have to mention all the non-zero digits. You have to mention all the non-zero digits with a decimal point after the first digit. So here we have got 2 non-zero digits, 35. So I'll write it as 3.5. Both the digits are mentioned with a decimal point after the first digit. 1, 2, 3, 4 and 5. The decimal point is moved 5 digits towards the right. So it is 10 raised to minus 5. Now in this sum, there are only 2 non-zero digits, but there is a 0 in between the 2 non-digits number. So here you will have to mention all these 3 digits. So this is some new type of rule coming here. There are only two non-zero digits, that is 4 and 5. But there is a 0 between 4 and 5. So here the rule says you have to mention all the zeros between the two non-digit numbers. So I should able to write it as 4.05. Means I mentioned all the 3 digits. No decimal point means a decimal point at the end, moving 1, 2, 3, 4, 5 and 6. So it is 4.05 into 10 raised to 6. So I hope you are clear with now how to write numbers in the standard form. Yes, again the rules: mention all non-zero digit numbers. So you have to mention all non-zero digits. Okay, if there is a 0 between them, you have to count all of them. You have to count the 0 between them. The decimal point comes after the first non-zero digit. Decimal point comes after the first non-zero digit. If you move the decimal to the left, the power is positive. If you move decimal towards the right, the power is negative. So this is the rule of writing numbers in the standard form. Now after writing the numbers in the standard form, we will start to compare them. Now, the diameter of the sun is 1.4 into 10 raised to 9 meters. So this is written in the standard form. And the diameter of the earth is 1.2756 into 10 raised to 7 meters. So you can see what is the standard form. There are only 2 digits which are non-zero with a decimal point after the first digit. Here there are 1, 2, 3, 4, 5. 5 digits which are non-zero with a decimal after the first point. Now you have to compare the size of the sun, the diameter of the sun and the diameter of the earth. So this is not comparing the size. We are comparing the diameter here. So let us say this is our earth and this is the diameter of the earth. How much big is the diameter of the sun compared to diameter of the earth? So to compare them, we'll write diameter of the sun compared to diameter of the earth. This is 1.4 into 10 raised to 9 upon 1.2756 into 10 raised to 7. I can write this as 1.4 as 14 upon 10 into 10 raised to 9, and this I can write as 12756 upon 10,000 into 10 raised to 7. Now you can see, to compare this is 10 raised to 9 and this is 10 raised to 7. I either have to make this 9 into 7 or the 7 have to turn into 9. Now what does 10 raised to 9 mean? 10 raised to 9 means 9 zeros after 10. So 1, 2, 3, 4, 5, 6, 7, 8 and 9. So there are 9 zeros, but I want to complete it into 7. So how many zeros are left? 2 zeros. So I can write 10 raised to 9 as 10 raised to 7 into 10 raised to 2. So what I have done here, this 9 I have written as 10 raised to 7 into 10 raised to 2. So I can write this 14 upon 10 into 10 raised to 7 into 10 square, that is 100. So this becomes 100 upon 12756 upon 1, 2, 3, 4, 10 raised to 4 into 10 raised to 7. So this 10 raised to 7, 10 raised to 7 can now get cut. This 0 and the 0 can get cut. So we are left with 14 into 10. And when this number goes into the numerator, it becomes a reciprocal. So it becomes 1, 0, 10 raised to 4 goes into the numerator and 12756 in the denominator. Now how much is this? If you compare, what do you get? 14 tens are 140. So 140 into 10 raised to 4. So there are 4 zeros added. 1, 2, 3, 4 upon 12756. Now because we want to approximate, you see this 140 and 127 are mostly equal. So 12,756 can be taken as almost equal to 14,000. So how many zeros left here? 2. So if we consider that this digit is almost equal and it becomes 1, then we get 1, 0, 0 approx. So the diameter of the sun is approximately 100 times more than the diameter of the earth. You can see here we have not done the exact calculation. You can even do that if you know the division, but on an approximation, these both are equal. 14,000 is almost equal to 1276. So the diameter of the sun is approximately 100 times the diameter of the earth. In the next question, we have got a red blood cell whose size is only this much and plant cell whose size is this much, and both are in meter. Since they both are in meter, we do not have to do any conversion like we did in the previous sum. So size of the red blood cell compared to the size of the plant cell. First, let me write in the standard form. How do I write in the standard form? There is only one digit non-zero, so I'll write 7 into decimally shifting towards the right 1, 2, 3, 4, 5 and 6. So into 10 raised to minus 6 upon 4 digits which are non-decimal. So 1.275 into decimal shifted 1, 2, 3, 4, 5, 5 places it is shifted. So 10 raised to minus 5. Okay. Now this is minus 6 and this is minus 5. So what I can do is I have written the standard form. Now here writing the standard form is making it slightly complex. So is there any other method we can use? We can try this first. We can write this 7 upon 1, 2, 3, 4, 5, 6. So I'll write 6. 1, 2, 3, 4, 5, 6 upon 1275 upon 1, 2, 3, 4, 5, 6, 7, 8. So I'll write here 1, 2, 3, 4, 5, 6, 7, 8. Now I cut the zeros 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So this is what is left. After cutting the zeros, yes, there is 1, 2, 3, 4, 5, 6, 7 and 8. 1, 2, 3, 4, 5, 6, 7. Okay, one more zero I have to put 8. So this is what is left. Now it goes in the numerator, so it becomes 7 into 100 upon 1275. That is 700 upon 1275. Now you can see this 700 twos is 1400. So if I multiply this by 2 and divide this by 2, I get 1400. This is 700 into 2, 1400 upon 1275 into 1 upon 2. Now I consider this to be almost equal. This both are almost equal. So I can say the ratio is 1 upon 2. Means the red blood cell, yes, is double in size than the plant cell. Red blood cell and the plant cell. Okay. So I can write red blood cell, or I can cross multiply this and write 2 times the red blood cell is the plant size of the plant cell. So the plant cell is twice in size than the red blood cell. Okay. Now in the next sum we have Mass of the earth is given in the power 10 raised to 24 and mass of the moon is given in the power 10 raised to 22. We have to find the total mass. So total mass will be mass of earth plus mass of moon, that is 5.97 into 10 raised to 24 plus 7.35 into 10 raised to 22. Now because the powers are both different, the decimal places are at different positions, so we cannot add them directly. So to add the mass, we'll have to first put them into proper decimal places. So I will write here as 5.97 into 10 raised to 22 into 10 square. So two zeros have split up, 24 is 22 plus 10 square, and this has 7.35 into 10 raised to 22. Now this decimal point and this decimal point is the same, means they are properly aligned, the same powers. So now what remains here? 5.97 into 100. 10 square is 100. So 5.97 into 100 becomes 597. So this becomes 597 into 10 raised to 22 plus 7.35 into 10 raised to 22. Now I can add both these numbers. So what will I get after adding them? I will get after decimal point 0.35. 7 plus 7 is 14, 4 carry 1, 9 plus 1 10, 0 carry 1. So it becomes 604 into 10 raised to 22. But by rule, the decimal point has to be after the first digit, so I have to shift it 2 towards the left. So it becomes 6.0435 into 2 decimal I have shifted, so 22 becomes 23 and 24 positive integers, so 24 kg. 6.0435 raised to 24 kg is the mass combined of the moon and the earth. So this is the way how you arithmetically add or subtract the standard numbers in standard form. So I hope you understood what is the standard form. Three sums we have done here of comparing sizes, bigger sizes and smaller sizes. We have to get an approximate while comparing. Okay, we do not go for the exact or accurate ratios right now. We are going by the approximations. So in this class we will only go by the approximation. In the further classes, in higher standards, you will learn how to go by accurate measurements. So for the homework, you have got exercise 12.2, which you have to do in the rough book. Tomorrow we will solve the exercise in the next video. So try to solve this on your own. You can see the video twice or thrice till you understand the concept thoroughly and then try to solve the exercise. So I'm going to end here. Thank you.